Hey guys, it's Lord of the Pogs. Ever since humans began to look up and see the night sky, people have been fascinated by space travel. From Jules Verne's From the Earth to the Moon, published in 1865, to 2001, A Space Odyssey by Arthur C. Clarke, published in 1968, people have dreamed of traveling to space. In 2024, space probes have visited almost every celestial body in the solar system. In 2024, space probes have visited almost every celestial body in the solar system, and at least 4 celestial bodies have had space probes physically land on its surface. Humans have only visited the moon, but there has been talk of a manned mission to Mars for some time now. And in the 1970s, NASA considered a manned flyby of Venus. But what if you could visit every planet in the solar system? In this video, we're going to imagine taking the ultimate road trip, where we visit all 8 planets and Pluto. The whole journey is going to take us about 25 years, so we'll need a spaceship that can get us there and home, as well as pods that can get us to the surface of each planet and back. The manned flyby of Venus that NASA considered in the 1970s would have utilized old hardware left over from the Apollo program, which was produced but never used to go to the moon. The interior of the fuel tank of the S-4B would have been a living quarters, but this setup isn't practical for our trip for a number of reasons. First of all, the manned flyby of Venus would have lasted 14 months, but our trip is going to take us 25 years. Secondly, as a flyby mission, there was no landing apparatus. Even if there was, the lunar module is only good for landing on a surface with no atmosphere. And the command module is good with a heat shield, but once it lands, there's no way for it to take off again. The most realistic, and I'm using the word realistic very loosely here, the most realistic option is to use an expanded version of Discovery 1 from 2001: A Space Odyssey. Discovery 1 has an area for the crew to go into suspended animation, which is necessary because there will be so much downtime as we're traveling from one planet to the next. Discovery 1 also has 3 auxiliary crafts called pods, but our version of Discovery 1 will contain 9, 1 for each visit and 1 for the return to Earth. We'll call it Discovery 9. Since getting to Mars requires a Hohmann transfer, which involves going around the sun, we'll visit Venus first. Getting to Venus will take 4 months, but because of the suspended animation, the trip will feel instantaneous. When we get there, we'll use the first pod to enter the atmosphere, and radio blackout will last 6 minutes because the atmosphere is so thick. In fact, it's so thick that once radio blackout is over and the parachute is deployed, descent to the surface will take over an hour. It will feel less like descending through an atmosphere and more like descending through a viscous liquid. We won't even be able to see the surface until we get to about 20 miles. When we land, it will take about 10 minutes for the dust to settle. It won't be very bright since only about 10% of sunlight gets through the clouds, and the temperature at the surface will be about 900 degrees Fahrenheit. It's a rocky surface like a desert, but it's so incredibly hot that when we get out of the pod, the ground beneath our feet will feel more like a mushy candy bar. The pressure outside is a crushing 1,300 pounds per square inch. The maximum pressure range for a military submarine is 700 pounds per square inch, and the water pressure in a pressure washer is 1,000 pounds per square inch. We can go outside for a minute, but the air pressure will feel like a 100-pound person sitting on your shoulders. The atmosphere is sulfuric acid, so once we re-enter the pod and take off our helmets, it will smell heavily of rotten eggs. We'll feel a burning tickle in our nose and throats if we breathe in too deeply. In fact, we'll need to wear oxygen masks while we pack away our spacesuits, then repressurize the cabin with fresh air, to avoid passing out. After leaving Venus, it's just 25 days to get to Mercury. Landing on Mercury will feel a lot like landing on the moon. There's no atmosphere, and the ground has no color. The Apollo astronauts landed with the sun behind them so they could use the shadow as a reference for how close they were to the ground, and we'll land the same way. But the temperature on Mercury is much more extreme. On the moon, the temperature in the sun is 250 degrees Fahrenheit, and in the shadow, it's 208 degrees Fahrenheit below zero. On Mercury, the temperature in the sun is 800 degrees Fahrenheit, and in the shadow, it's 290 degrees Fahrenheit below zero. We'll still land on the day side so we can see, but we'll land near the terminator where it's somewhat cooler, the line between light and shadow. Once we're here, it won't be very exciting. The sky will be completely black except for the sun, which will be as bright as a searchlight and almost 5 times bigger in the sky than on Earth. It will be about the size of a volleyball if you hold it at arm's length. The Earth will be the brightest star in the sky, and with binoculars, you'll almost be able to make out the moon. Since we landed near the terminator, the sun will be on the horizon, which means long shadows. Since the surface of Mercury is dark gray, it will almost be too dark to see anything. From Mercury to Mars, it's a 25-month trip. This is where we use the Hohmann transfer to place Discovery 9 into an elliptical orbit and catch up with Mars as it's moving. Landing on Mars won't be entirely different from landing on Earth. We can use a parachute, but depending on where we choose to land, we might need thrusters to pick a good spot if the wind catches us. Viking 2 landed in Utopia Planitia, and Mars Pathfinder landed in Eris Vallis, both areas which are strewn with small boulders, and Curiosity landed near a Gale crater which is relatively smooth. So a more controlled landing than what a parachute could provide would be preferable depending on the terrain. At the equator, it's been known to get up to 80 degrees in the sun, but we won't want to go outside without a spacesuit. There's no oxygen on Mars. The atmosphere is entirely carbon dioxide, so we'd start to feel dizzy right away and pass out after just 15 seconds. Because the atmosphere is so thin, our blood would boil. Even though Mars is 50 million miles further from the sun than Earth, the thin atmosphere wouldn't protect from radiation as well, and we'd experience severe sunburn much faster. So a good spacesuit is imperative if we want to go outside. The sun will appear half the size as on Earth, about the size of a marble held at arm's length, and even on a clear day, it will only be as bright as an overcast day on Earth. Mars has 2 moons, Phobos and Deimos, which orbit in opposite directions. If we see them pass each other, Phobos will look like a small potato in the sky, and Deimos will be the brightest star and visible during the daytime. We'll be able to see Earth from Mars too, but it won't be an obvious planet. It will just look like another star visible during the daytime. We can see Deimos moving in its orbit, but Earth will be stationary. With binoculars, we'll be able to see the moon next to Earth. Once we leave Mars for Jupiter, we'll need to go into hibernation, or it will be a very long, boring 3-year trip. We'll need to go through the asteroid belt, which is mostly empty space. On average, objects in the asteroid belt are about 600,000 miles apart from each other. The largest object in the asteroid belt is Ceres, about 600 miles across. Vesta, Pallas, and Hygeia are all around 300 miles across, and everything else in the asteroid belt ranges in size down to a few feet. We might be able to see Ceres with a telescope if we were looking for it, but unless we were very close, we probably wouldn't see it with the naked eye. In fact, we probably won't see anything in the asteroid belt at all. From here, Jupiter would appear about the size of the moon from Earth, and its 4 biggest moons, Io, Europa, Ganymede, and Callisto, would be the brightest stars, and it would get gradually larger as we get closer. We're going to go into Jupiter's atmosphere when we get there, but there's no solid ground to land on. As we get ready to descend, most of Jupiter's moons will appear as bright points in the sky, brighter than stars but not easily identifiable as moons. Depending on their positions and where we are on Jupiter, the four largest moons will appear larger and brighter than the moon from Earth. Io is volcanically active, so we'll be able to see volcanic activity through a pair of binoculars. We'll need a parachute since trying to land on Jupiter will be like landing on a cloud. But we'll need a powered engine to get us back out. Due to Jupiter's immense gravity, we'll be traveling about 100,000 miles per hour when we hit the top of the atmosphere. But we'll need to make sure that we're strapped in for when we hit the much denser atmosphere below. Imagine driving a truck into a concrete wall. After about 3 minutes, we'll hit the cloud tops where the wind is blowing about 300 miles per hour. After about an hour, we'll be about 100 miles below the top layer of clouds. It will be completely black because no sunlight makes it down this far, and the pressure will be about the same as if you were to visit the Titanic wreck. This is further than the Galileo probe made it in 1995 before it was crushed by the pressure. When we reach 450 miles down, Jupiter's atmosphere will begin to absorb radio waves, so we won't be able to communicate with Earth from here, and not even with Discovery 9. Assuming our pod and the parachute can withstand the pressure and the temperature, after descending for 12 hours, the temperature will be over 6,000 degrees Fahrenheit, hot enough to melt tungsten. At 13,000 miles down, the temperature is hotter than the surface of the sun. And this is where things start to get weird. The pressure here is about 2 million times more than on Earth. It's so much that hydrogen atoms are so compacted together that there's physically no room for electrons, and it creates a substance called metallic hydrogen. It's still a gas, but it's as dense as rock. And if we were to shine a flashlight at it through the pod windows, it's so reflective it would be like staring into the sun. From here, it will take us about 7 hours to get back into orbit. From Jupiter, Saturn would only be a fraction of the size of the moon as seen from Earth, but it will be substantially brighter, and you might even be able to see Titan. We're going to go back into hibernation because it's going to be another 2 years before we get there. As we approach Saturn, the rings will still appear to be a solid disk until we get almost close enough to touch it. Most of the particles in Saturn's rings are about the size of a grain of sand, but depending on which ring, they can get up to the size of a bus. The thickness of the rings varies from about 15 feet to more than 15 kilometers. After we pass Saturn's innermost ring, we still have 175,000 miles to get to Saturn itself. About 4,000 miles above the cloud tops, we can look north or south and see Aurora Borealis and Aurora Australis, just like on Earth, but significantly brighter. From here, we will be able to see Titan about the size as the moon from Earth, but significantly brighter than a full moon at night. We might be able to see some of Saturn's other moons like Mimas or Enceladus as bright points of light, but if Titan is present, it will be too bright to see any other moons. When we get to the cloud tops, we'll encounter 900 mile-per-hour winds, almost 5 times stronger than Hurricane Wilma, the most intense hurricane ever recorded. Outside the windows, we'll see yellow clouds, and if we were to venture outside, our spacesuits would smell like ammonia when we came back in. About 200 miles down, we'll encounter water, which strikes our pod like heavy rain in the 300 mile-per-hour winds, and eventually turns into ice like hail. Not because of the low temperatures, but because of the immense pressure. The liquid water becomes almost indistinguishable from a solid. As we continue to descend, we'll encounter rain again, but this time it's liquid hydrogen, and eventually we'll see more metallic hydrogen just like on Jupiter. Once we get through the metallic hydrogen, we'll reach Saturn's core of iron and nickel, which has a Once we get through the metallic hydrogen, we'll reach Saturn's core of iron and nickel, which has a surface temperature of 149,000 degrees Fahrenheit, hotter than the surface of the sun. It will take about 4 hours to get back into orbit. From Saturn, Uranus will be the brightest star in the sky, and it will take us over 2 years to get there. When we get there, we'll pass the rings. The outer rings are bright, but the inner rings are narrow and harder to see because they're so dark and mostly dust. All the rings together are about 45,000 miles wide, and after we pass the innermost ring, we'll still have about 20,000 miles to go before we get to Uranus. We'll be able to see the moons Titania, Oberon, Umbriel, Ariel, and Miranda smaller than our moon and significantly darker. The top layer of atmosphere is hydrogen sulfide. If we put on our spacesuits and roll down the window for a minute, when we repressurize the cabin, it will smell heavily of manure and onions, and it'll sting our eyes. Below the top layer of atmosphere, we'll find methane, which is so dense that it will feel more like swimming. As we continue to descend, we'll begin getting pelted by diamonds like hail and wind blowing more than 500 miles per hour. Since methane is a single carbon compound under this immense pressure, the methane molecules will break apart and crystallize into diamonds. When we get to the mantle, it will be completely dark. The mantle is made of ammonia, water, and methane, and walking on it will feel like walking through slush. Snow, after it's rained, then froze. It will take us about an hour and a half to get back into orbit. From Uranus, Neptune will be the brightest star in the sky, and it would be another 2.5-year journey. When we get there, the sun is so far away that the most sunlight we'll see will be like a full moon on Earth. We'll be able to see Triton, about half the size of the moon from Earth, but most of Neptune's other moons are too small or too far away to see. The wind at the top of the atmosphere will be blowing over 1,000 miles per hour. As we descend into clouds of ammonia and hydrogen sulfide, the temperature rises to 900 degrees Fahrenheit before it turns into slush. Here we'll find more diamonds, but instead of falling like rain, they'll be about the size of basketballs, and they'll just sink into the slush, which is about 12,000 degrees Fahrenheit. There is not much to see. The slush just gets thicker and thicker until it's more like a solid. From there, it will take about an hour to get back into orbit. From Neptune, Pluto is too small and too far away to see, even with a telescope. In fact, we won't be able to see it at all until we're about 1,000,000 miles away, which is a lot closer than it sounds. Pluto is so incredibly small that we won't need much thrust to get to the surface. Depending on the season and where we land, Pluto may or may not have an atmosphere. If it does, it will be too thin to use a parachute. If we land on Pluto at the right time, we will actually see the atmosphere freezing and falling to the surface like snow. If we get to the surface and there's powder on the ground like frost, we know we're in the cold season, and there's no atmosphere right now. The sun will be the brightest star in the sky, slightly brighter than Jupiter is from Earth. Depending on what part of Pluto we land on, we might see ice mountains over 10,000 feet tall, and the surface will either be black, white, or a deep crimson color. Pluto's largest moon, Charon, will look eerily similar to Pluto and be about 8 times bigger in the sky than the moon from Earth. The surface of Pluto and Charon are the same, and even though it's twice as reflective as the moon, being 40 times further from the sun than Earth means that Charon will be about half as bright as the moon in the sky. Even though the sky will be completely black, the surface will still be about as bright as an overcast day on Earth. Pluto has 4 other moons besides Charon, but they're so incredibly small that they will be indistinguishable from stars in the sky. We might be able to see them move if we watch them long enough. From Pluto, it will take us about 9 years to get home, and even though we've been gone for about 25 years, we will have hardly aged at all because most of that time was spent in suspended animation. But that's a topic for another video. Thanks for watching. If you could visit another planet, which one would you like to visit and why? please let me know down in the comments. If you enjoyed this video, which I hope you did, please like, share, and subscribe, and hit that little bell in the corner to get notifications on more videos like this one.